All right. Welcome, everyone. We are live. Thank you so much for joining our LinkedIn live stream today. My name is Gilberto Hernandez. I'm a lead developer advocate here at Snowflake. I'm really excited because today we're going to be talking about a couple of features that I love to use within Snowflake. So, first is dynamic tables. You may be familiar with them, you may have heard of them, but they have kind of grown in scope to add new features and capabilities recently. So, we're going to cover a bit of that today. The second thing we're going to cover is Iceberg, everyone's favorite open table format. And we're also going to talk about how these two come together in Snowflake to help power your Lakehouse pipelines. So before we have quite a bit to cover, but before we get into it, just want to give folks a heads up. This is a live event. So if you have questions, if you have comments, feel free to drop them. If whether you're watching via LinkedIn or YouTube, we'll be able to see your comments. We'll be able to see your questions. And then towards the end, we're going to have a Q&A session where we're going to try to answer as many questions as possible. And if we're not able to get to your question today, we will come back to your question and answer it on either LinkedIn or YouTube. So again, this is a live event. Please go ahead and drop in your questions and comments throughout the show. All right, so let's go ahead and kick things off. Today, I am joined by my colleague and expert here at Snowflake on these features. His name is Parag Jain. Parag, welcome. Thank you so much for being here. Before we kind of get into the agenda, I wanted to give you, just a few seconds to introduce yourself.
Sure. Thank you, Gilberto, for inviting me for this live demo. I'm Parag Jain. I work as a field CTO in Snowflake and primarily for data engineering. So I take care of all the transformation and compute and data engineering features in Snowflake.
Awesome. Yeah. All right. We're excited to have you here. As I mentioned, we're going to be covering dynamic tables. We're going to be covering Iceberg. So I figured that before we get into our live demo for later today, maybe we can set the stage for folks and just give them a quick primer on the couple of things that we're going to be covering today. And maybe we could start with Iceberg, Parag, and maybe give us an overview for folks who aren't familiar. Maybe they've heard of it. Maybe they're curious about it, what Iceberg is. And I'll go ahead and hand it over to you so you can walk us through that.
That's fantastic. Yeah, sure. So I do have a couple of slides for that. And it will be interesting to just see how these two features combine and then get along together. So before we move on, this is just a safe harbor disclaimer. There are some slides that might be futuristic, maybe talking about some future features, but that should be okay. Before we jump onto dynamic table, I just want to make sure that everybody understand the open table format in Iceberg tables. So Iceberg tables have been kind of taking the world for the Lakehouse open table data formats because of their cool features that they come with. They have schema evolution. There is no hidden partitioning like Hive tables. They come with built-in time travel, snapshotting. They also come with built-in increased performance because they provide very fast filtering and scanning. Now, some of the folks might already be aware of Iceberg table because it is so popular and a hot topic in the industry right now in terms of data engineering and Lakehouse. It also provides very flexible cataloging, and that's one of the reasons why Snowflake has adopted it, because it does provide an open table format plus an open catalog feature as well. And Snowflake has released its own open catalog as well in terms of REST API-based catalogs. We also support positional deletes in Iceberg tables. So that also comes in very handy when you're building a pipeline and when you want to actually make fast changes to your data. Now, based on what we have for today, it's important to understand how and what dynamic tables work and behave with Iceberg table. So before we go there, just a quick primer on dynamic tables. Snowflake has introduced dynamic tables a couple of years back. They are a declarative way to actually create an ETL framework and a batch-like pipeline or a streaming pipeline. They are really cool because they do provide full observability and visualization using DAG. We can use them to create alerts. We can use them to create data quality pipelines. We can use them to create any incremental or full refresh pipelines between different tables, different base tables, even between dynamic tables as well. So if you create a dynamic table, which is actually a physically stored data, similar to what we use it for Mertlize View, but has many enhanced capabilities, including scheduling capabilities and orchestration capabilities as well. So dynamic table does come in very handy, and we have been using it for many years now. But very recently, we have introduced dynamic Iceberg tables, which are dynamic tables, but now you can build Iceberg tables using dynamic tables. So we'll see that in a demo as well. Um, at the core, dynamic table provides three important features. One is it can store your results, and let me turn on my laser lights. It can provide you, it provides you a way to store the results. So it's not just like a SQL query or a view, but it actually stores the results. It can automatically refresh based on a time lag. So that's a very important feature, because many times you receive data and then the pipeline runs whenever, whatever, maybe 4 hours, 5 hours, and you still have data. So instead of that, you can do an automatic refresh as soon as your base table has data. Your dynamic table can store the data using a pipeline that you built using select statement. So you can add any query in the select statement. We do support many different functions like window functions as well, lateral joins as well. Um, when the time comes to actually query dynamic table, there is no magic. You can just use simple plain old SQL select statements to query the data. Based on your data freshness and lag, you will get the data at that point in time. It also gives you a snapshot isolation as well. So even if the dynamic table is running behind the scene, if it is already has materialized a previous result, you get to see those results even if it is running behind the scene, even if it's running the data pipeline behind the scene. So those days are gone where you actually have to clone your data because your pipeline is running, so people don't see different results. That is now built in. The snapshot isolation is built into dynamic tables. You do not have to do all that. So it gives you a very good set of operations, so that you do not have that burden of operations overhead when you actually build a pipeline using different tools, maybe stored procedures, task, or you have an Airflow pipeline running some SQL scripts. You don't have to do all that. The infrastructure is gone, plus the operational burden is gone. Now you get these things built into something like dynamic table. So here are some key highlights how other customers of Snowflake are using dynamic table for. So it's a very good tool for low latency freshness. So if you're receiving your data, let's say from a streaming pipeline, and you want to build upon that data and present this to your customer, you can go as little as a single-digit second to a minute. You can build declarative pipeline for something like Iceberg table. You can build declarative pipeline with Python support. You can observe that pipeline through a single monitoring screen. You don't have to switch over from, for example, if you have Airflow pipeline, you have to switch over to Airflow to monitor the pipeline, see the logs if something has failed. But here in dynamic table, you get a singular view of your DAG and of your pipeline through a monitoring screen. It also creates a sort of dependency graph. This dependency graph is live. Basically, you can click on these objects, you can pause your pipeline, resume your pipeline. You can see what's the code used in that pipeline as well, change the lag as well. So at any point of time, you get this view, and then it becomes very easy for an engineer to delegate this to this operational team. So you take away that pain of hand-holding your operation team with the development team. So you get this separate segregation of duties for different teams as well with that view. That's just one example, but it gives a nice observability of your pipeline live on your screen. It supports joins, window functions, like I said before, aggregations and views. It gives almost everything in your war chest to create a pipeline. Now with dynamic table, the support for Iceberg table is one thing, but we are also working on many different things with dynamic table to increase the power of dynamic table. One of the few things that I like about this new power is immutability. So imagine you're creating a table, and this is a live table. This is a dynamic table which you will incrementally refresh, but you don't want to change certain data because, let's say, for compliance reason, if you have 5 years worth of data and you do not want to change last 3 years worth of data in that pipeline, then you can make that region of your table immutable. That's a really cool feature. So it restricts any sort of insert, update, deletes on that region. You can now also do outer joins with highly performant dynamic tables. You can operate on top of clustered keys. You can operate on top of mask tables, so you get the same masking in dynamic table built in as well. So all these are very cool features which gives you more control on your data and also gives you high performance. So this is the thing about governance that I was talking about. If your base table or on your source table where you drive your dynamic table on, if it has these governance policies, those governance policies are easy to transform into dynamic table as well. So you don't lose that governance, you get that singular governance. And based on what we just saw, there are many use cases of dynamic tables. Some of them are listed on your screen. All these use cases have been battle tested so far in dynamic table, and they work great. I'd highly recommend dynamic table with Iceberg table or without Iceberg table to everyone. Back to you, Gilbert.
Awesome. Thank you so much, Parag. You covered quite a bit there, so I appreciate the primer. It sounds like dynamic tables pretty easy to pick up because you're just defining them with SQL. You can schedule them based on your use case, and you don't have to use any third-party orchestration tools to do that. You have a native way of doing that directly within Snowflake. Observability too, right? It sounds like once you
Yeah,
set them up, you can go ahead and check out the DAG, see how they're linked, see the relationships with tables. That's pretty cool. One thing that I tend to hear from builders out there when we talk about dynamic tables, frequently we'll talk about why how they are declarative by nature. And I'm curious if you could just elaborate a little bit more on that. So, in your eyes, why is a declarative approach for pipelines so powerful?
yeah. So it actually abstract away the pain, right? So for example, compare this with let's say an ETL tool. And it's a GI based ETL tool where you're dragging and dropping and creating your pipeline through some GUI, and then ultimately you create a workflow and then you deploy that workflow and then orchestrate that workflow. There are multiple step processes, but if you look at a data platform like Snowflake and you draw ETL pipeline using a GUI tool, that ultimately creates a SQL and then pushes down to Snowflake. If you have hands on that SQL, and if you can just use that SQL to create a pipeline, that's magic. That's something that Snowflake has brought to you now. And that's what the declarative nature of pipeline is. You can declare your pipeline using the simple select statement. It's basically a view that you want to see of your data, and then Snowflake make it happen, create a physical stored table out of that view.
Right. So rather than having a bunch of different scripts and steps that you might have to take, you basically have a pipeline defined in an object, which is pretty cool and easier to maintain, I should say.
100%.
Yeah. One more thing I wanted to call out is they're incremental, right? So they're going to process only the new changes that have landed in the source data. I think that's been around since dynamic tables is launched. I think another cool thing that folks should consider as they use this feature is immutability, which you touched on a bit, right?
Yep.
So can you touch a little bit just quickly on how you can, how immutability helps incremental refreshes?
Yeah, I see a very defined use case of immutability is compliance. There are many other use cases as well of immutability, but let's take compliance for example. You work in a financial organization, and you have to make sure that your data doesn't change for past year because you already reported, let's say, your quarters or your years in your 10K, and you don't want that data to change. and you have a dynamic table pipeline. Now, errors can happen because we are all human. So even with that error, you do not want to update your previous data sets or historical data sets. And that immutability through dynamic table gives you that tool to lock and secure that data, even if anything changes in the source. So that's where immutability comes very handy. It won't let you do inserts and updates or deletes on your immutable region. And that can be defined by date, that can be defined by any column or filter value.
Awesome. Yeah, I love that. It's a simple where clause, you're right, for most of these use cases, which is really
Yes.
cool, easy to implement. So
Yes.
cool. I think we're ready to hop into our live demo, Parag. Right.
Awesome.
So you're going to be so Parag is going to be showing us a pipeline he's built with dynamic Iceberg tables, and he'll kind of showcase some of the features that he just discussed along the way. So I'll hand it over to you, Parag. Thank you.
Awesome. Thank you, Gilberto. So before we jump onto the demo, yes, there is a hands-on lab available for this for you to try and test. The link for this hands-on lab is here. It's my GitHub repo, and all the source code is there. And I'm going to walk you through this source code and this demo architecture as well. Uh, so for this demo, we're going to have two tables as our base table, and they are Iceberg tables. You can have them as Snowflake tables as well, but they are Iceberg tables. One of them is products, and other is orders. Think about a simple e-commerce website where you were selling your products and you're getting orders from different customers, and you want to generate some metrics out of it. You want to generate how my sales are doing. So you want to do some kind of sales summary report. You also want to enrich your orders table based on the product, just to figure out if you're not running low on inventory for a certain product. So that's the goal layer that we are going to build. And this circle sign inside a box is our representative of a dynamic table. So we are creating a dynamic table, but it's Iceberg. So that's why we're calling it DIT, Dynamic Iceberg Table. So ultimately, your gold layer will be an Iceberg table. Your bronze layer is already an Iceberg table. What is the benefit of this? It gives you data in your control. So it's there in the open storage format, meaning it's in the Iceberg table. At any point of time, you can connect any external system without Snowflake to this Iceberg table. You do not need to connect to Snowflake to read these tables. It gives you an Iceberg built-in Iceberg REST API-based catalog. Many tools and platforms support Iceberg REST catalog, so you can connect to Snowflake seamlessly. It gives you built-in managed data pipeline and in dynamic tables, so you can observe your tables, build incremental data. You can have interoperability with the Iceberg tables. You can centralize the governance, access control, all that thing that doesn't come with Iceberg table are provided by Snowflake, including a dynamic way to build your Iceberg table. So let's just jump onto this demo. And while I'm presenting this demo, if required, I can switch back to this image as well, just to show you in which step of the pipeline we are. All right. Okay, so let's go to the workspace. This is Snowflake Snow site. In its full, it looks like this. What I've done is I went to projects workspace, right? And I'm gonna minimize the panels that we don't need. And I have opened up one of the labs that I've built in my GitHub repo. So step by step, there are many SQL files, and they are numbered, so you won't be lost. So you can start with setup, then create source tables, then create dynamic tables, and then provide different operations for your dynamic table. What I've done is I've listed all these steps in a notebook file, and Snowflake Workspace supports both SQL and Python notebooks. So I put that in the notebook file because it's easier for me to demo and talk about the demo. So I put that in a notebook. I can share the notebook as well in the hands-on lab. I haven't, but I can share it. It's basically the exact same SQL. So what do we need for our dynamic Iceberg tables? We first need a dedicated database and a schema, and then and a warehouse to run our compute. So that's what I've created here. The database I'm calling DTI is demo, and the schema is demo. And then I'm using the warehouse that I've created earlier. Now this step is crucial because your data resides in a chosen bucket, customer chosen bucket. You have to connect to that bucket. And this is how you can let Snowflake know that this is where my data should reside. So you create something called as external volume. Now within few sentences and within few properties, so you will provide your S3 bucket, you'll provide your role where Snowflake can use that role and connect to that external volume, and any safe keyword that you want to disclose. This way you can create the external volume. Now, this is not just one step. Once you create the external volume, you have to let your CSP, cloud service provider, go back to cloud service provider and approve this external volume. So it's very secure. It's not just one way to simply just get the AR and connect, but you also have to approve this connection. And the step for that is also mentioned in the file as well. But it's super easy. You will allow writes, so Snowflake can write to their that as S3 bucket. This role should have write privileges on the S3 bucket as well. Once you create that, so let's just quickly run this just to see if everything is in place. All right, so it looks like we have our database schema and external volume created. Let's move on to the next step. Now in this step, as discussed, we have a bronze layer to create, which is our product layer and the order layer. And these two tables are actually Iceberg tables. Super simple to create in Snowflake. All you need is just create or replace statement. Everybody should be familiar with this. When you create an Iceberg table, you need to provide the external volume. This is the same external volume that we just created. For catalog, it will be Snowflake. Snowflake creates Iceberg REST catalog by default. So for you to connect with any external platform or system, like for example, Spark, if you want to connect to through another database, let's say Oracle wants to connect to this Iceberg table, you can do that as well. Any platform that supports Iceberg REST catalog should be able to read this very seamlessly. Now within our base location, and let me just go to my base location that I'm using. I'm using this bucket in Snowflake, and let me just refresh. Right now, there is nothing in this bucket. And what I'm going to do is I'm going to create my first table, which is the products table. It's created, and then I'm going to insert some data in it. All right, looks like we have data there. So now we'll just refresh, and there you go. We now have the Iceberg table created in my chosen bucket, and this table has two things, two folders. One is data, and the other is metadata. And metadata has basic Iceberg metadata with Avro files, metadata.json file as well. Then we have in the data folder, we have Parquet dataset, the data that we just loaded. So very cool. We have our first Iceberg table, which is products table. Let's move on and create another Iceberg table, which is my orders, another base table that I want. Let's just create this. And it's going to be in the orders folder. So let's go back to our S3 bucket, go into tables, and now we have orders bucket, orders folder as well. And since there is no data, there is only metadata. We haven't loaded this table, so we only see metadata. Let's load this table a little bit with some data. There you go. And by the way, I'm using a very small compute for this. And let's go back and refresh. And there we go. Now I have data as well. All right. So let's quickly check the content of these two tables because we're going to need that in our demo. So for products, I have different products listed. These are all fake products that I just created. They have a category. So for example, laptop is an electronic category, and then I have some furniture category as well, and then some accessories as well. They have listed unit prices and the create on date. And in my orders table, I have customer ID, which have ordered the product, and number of quantity for that product, and some region information as well. Now, one cool thing about the orders table is it marks the order status as completed and shipped. We're going to need this in the future, so I'm just going to highlight this order status for now. Next is, let's check total number of rows. So in my product table, I have 10 rows, and in my orders table, I have 15. Cool. All right. Now this is our first dynamic table. What I'm going to do here is I'm going to create an Iceberg table using a select statement. And that's why it's called dynamic Iceberg table, because that select statement is basically trying to query these two tables, orders and products, to create my Iceberg table. As and when I load new data to orders and product table, my dynamic table will refresh incrementally only for this newly added data. All right, so let's create this. It's basically simple math, creating a total amount using the quantity and unit price, because the amount is missing in my orders table. So I'm enriching my orders table with actually a product name, its category, and the total amount. So a customer has paid so much for buying this product, and it's based on the unit price of the product, right? Very simple SQL. So I've just created it. Now the beauty is, in the beginning, when you actually create the dynamic table, it actually creates the data as well. So let's go back. There we go. Now we have orders detail, and it has data and metadata. So let's run a quick query to see if we have data in this table. So I'll just add a SQL and do a select star from orders detail DIT. Right, let me just quickly check the name. It's order details, not orders details. So just copy paste and then run. There we go. So now the enriched order table, which is order details DIT, has not just product ID, but product name, and it also has the total amount. All right, moving ahead. Now, one of the requests that I get from my business team is detail about the product, how we are, how much are we doing in terms of sale for individual products, what category is the top selling categories and all. So for that, I need a fact table which has summarized results for all the products. So what I'm going to do is create this summary table with my aggregated value for different figures of product and orders. Let's do this. Now again, this is a dynamic table, so it should automatically create the data. There you go. So if I go to not the order detail, sorry, the product sales summary, I do see data and metadata. All right, that's fantastic. So now let's moving on to different table. Now, one of the requests that I got from my business team is they want to see regional sales performance. And for that, we have to create metrics like metrics per region for different products that they have sold. So I've created a different SQL, and I'm going to use this SQL for this dynamic table. So let's run it. Few things to observe in all these dynamic tables is it has something called as target lag. Target lag, even if it is 30 minutes, and let's say your base tables do not have data after 30 minutes, do not have new data after 30 minutes, this will skip. So even if you have 30 minutes or 1 minute or 10 minutes, if your base table doesn't have new data, there is no point in running dynamic table. So you pay $0 to Snowflake for that. There is no compute consumption, even if your target lag is as small as 1 minute. unless there is data in the base table, unless there is change data in the base table. So that's a very cool feature of dynamic table, that even if all those cases where you have data coming in, let's say 2 p.m. it comes a burst of data, and then 2:30 it comes burst of data, but then 4 p.m. there is no data, then this dynamic table will have zero credits consumption. There is no cost that you will pay, even if your pipeline running every 30 minutes.
And
So
and
really
one,
cool.
Parag, just really quickly, I want to, because I think that's a really good point for folks to understand. And in addition to that, um, remember, this is a target lag, so it's like a maximum amount, of time that you're comfortable with, that you want your dynamic table to lag the source by. So, if you are using a dynamic table and say that you have set this to 30 minutes or 1 hour, an update can happen sooner than that, as I understand it, Parag, right? It can be anywhere in that window
Correct.
up to 30 minutes in this case.
That's absolutely right, and that's where that's where it's different from regular orchestrators or schedulers. Schedulers or cron jobs run at a definite time, and dynamic table, as soon as it sees the data is full, the new data is full. So it's not going to start at the first row. As it sees there is more insert or merge happening in the base table, once that is done, then the dynamic table is going to start. It's not going to start at every row ingestion. It's going to wait for that target lag. Now within that target lag, if your ingestion is complete in 10 minutes, it won't wait for 30 minutes. It will just start the uh, updates. So it's
Awesome.
really cool and very good point. Thanks, Gilberto. So, okay, this table is also completed. And this table has quite a few queries because it's a regional based matrix. So each region have different metrics and revenue categories that we are building. Now let's quickly go back to our S3 bucket, check if this table is also available. There you go. Now we have all the 5 tables, 2 base tables, and 3 dynamic tables available. Now, I talked about monitoring and observability in the pipeline. So how does it look like? So if I go here, there you go. I now have a database. And if I look at my dynamic Iceberg tables, I have 2 base tables. Now these are Iceberg tables, but then in the dynamic table section, I have 3 tables that I created recently. Let's look at one of them. This is the view that I was talking about in terms of observability. Is it creates this DAG-like structure, very similar to what you will see in Airflow or Airflow-like tools, where you can see the interconnection between a daisy chain between your base table and your dynamic table. Now, there are a few things that you can do here. You can either refresh this manually. So think about an operational engineer, something failed, and then you receive new data in the orders or product table, and you don't want to wait for that target lag. You can just refresh it manually. You can also, from here, see the details of the dynamic table. It will give you a definition of that dynamic table as well. You can also suspend. So for any reason, your base tables are in maintenance, or your dynamic table needs some maintenance, you can suspend this pipeline and start again whenever required. So it gives you a very good summary view of your dynamic table graph. In the refresh history, it gives you the pipeline when it will run, whether it was skipped or rerun. All that is possible through this view, single view as well. It gives you up to 7 days of view. It gives you all the refresh tables. So it has a built-in observability dashboard as well.
That's really cool. And today I learned you can refresh the table from the UI in the DAG. That's pretty cool. I was running alter table refresh statements in the worksheets,
Exactly.
but
Yeah.
that's pretty cool. And just to give folks a heads up too, Parag, you just showed how to see this in the UI. You can do those exact same things, so refreshing and checking out the refresh history with SQL statements too, right? So this is available to you as well if you want to check it out, writing a SQL query.
Absolutely. Yeah.
Yeah.
So I have those SQL statements as well for to review if you want to run it. And it's there in the GitHub repo as well. This is one of the SQL. You can just run the SQL to find out what was happening in my dynamic table, and it has many details listed out. Because many customers, what they do is, if, in terms of data pipeline, they take the observability to a singular dashboard somewhere outside of Snowflake. So this query comes in handy to pull that information from Snowflake.
That's handy. And as you think about combining this too with alerts and notifications, right? You could do that based on refresh history. Maybe you expected this to refresh incrementally or for something and didn't happen. Boom, like you can get a notification, tie that up to Slack if you wanted to, as an example. Very neat, very neat.
Yeah, absolutely. And so I just insert few more records in our orders table just to see if my dynamic table is refreshed. And here it goes. The 3 rows that I just added are now there in my dynamic table. So it does it incrementally fast. As soon as you insert new record, you can refresh your dynamic table immediately. Um, Now, in this section, I'm going to talk about the immutability that we have that comes built in with dynamic table. The only thing that changes. So, for example, I have this new dynamic table to showcase immutability. The only thing that changes in statement is this where clause. Remember, we had a column called order status. Now, what I want to do is create an analytic dashboard, and it should not change if the order status is completed. So if there is an order where the order status is completed, even if you change something for that order in base table, the status will preserve the data in dynamic table. So base table might change, but the order table, the analytical table will not change for completed status. So let's create this Iceberg table. All right, and let's check if there is an immutable region. Yes, so there is an immutable region. This is the orders column. What I'm doing is trying to query that same exact table and trying to find out if the column is immutable or not, and what's the value of that immutability. So just a simple SQL query. It tells me that if there is order status completed, it's immutable, and everything else is mutable. Very cool. So
That's amazing.
it
Yeah.
also, yeah, it also can tell me the number of rows. So 11 rows are completed, so that's why it's immutable. Now,
And this scales, right, really easily because you could imagine you have millions of records with order complete is true. So you locked them up just like that. Yeah.
yeah. Uh, Now here, I'm going to insert 2 records, 2 records in pending status. And then if you run this query, so there were 5 pending records. So if I run this query again, it should show me 7 now, and 11 are still immutable. Now, if you notice, the order ID is same, but it did not update it the completed. So now let's update the order status to completed and see what happens to the immutable region. There you go. So if you look here, because the order status is pending, and we tried to update a completed status, it didn't allow you to do that because it is immutable. So these are really cool features that are built into Iceberg table for you to actually write a SQL, or for you to actually build this into your pipeline. It will take many different iterations. It will take many different stages to actually do that. You probably have to copy data somewhere, then do a swap of some other data set, and then make your pipeline whole again. So all these things now built into your declarative pipeline. Really cool.
Very nice.
You can also choose a fixed cutoff for immutability. So in another example, I have my sales cutoff. So same example where I gave you about the quarterly results. So imagine every quarter you declare your results to Wall Street, and you don't want to change that data. So for that, you can make that region immutable, and this is changeable. You can come back and change the immutability region to, let's say, next quarter. It can be rolling. So you can make that all possible. That is it for dynamic table. Now, a few things to keep in mind that we have certain features that still do not work with dynamic iceberg table, and one of them is backfill. Backfill is not allowed in iceberg table, but it is allowed in the regular Snowflake table. Those things I've listed out in the README file as well, so you'll see those limitations in the README file.
That's super helpful. Great job, Parag. That was a very comprehensive demo. Really appreciate how you covered both aspects. Talked about dynamic tables, Iceberg, and then how you can do Iceberg dynamic tables, which is amazing. We're going to be sharing out the resources via the channels today, so on LinkedIn and YouTube. So if you are interested in those, check them out. So we're going to share the repo that Parag just walked through that includes all the SQL that you ran. I think you're also going to be updating it with that notebook as well, right, Parag? So keep an eye out for that. We're also going to be sharing a quick start guide that you can use to get started. So if you're interested in trying out dynamic tables, building autonomous pipelines to feed kind of your AI agent in Snowflake, check that one out. It's fresh, it's brand new. Check it out. Give us your feedback, but you can get started with dynamic tables really easily. So I know we're almost at time, so I don't know if we're gonna have time for a lot of questions. I do want to ask you one, Parag. It's one around that I hear frequently from builders who have built out pipelines today, and they have built out many materialized views as an example, and maybe this notion of dynamic tables. That might be new to them. So I'm curious for folks who are actively wanting to migrate from materialized views over to dynamic tables. Maybe a couple of questions. The first is, how are they similar? How are they different? Why might I pick a dynamic table over a materialized view?
Yeah, so Snowflake does support both, but materialized views can be created only on a singular table. Whereas dynamic table, you can have multiple joins for n number of tables. That's one thing. The materialized view pipeline is not so declarative, but the dynamic table pipeline is declarative and incremental, super fast, because it keeps the track of the changed rows in the base tables.
Awesome. And what could a migration of a materialized view object into a dynamic table look like? Is it as easy as it looks of just taking that definition for the materialized view and maybe putting it into the definition for dynamic
Yeah,
table?
yeah. No, 100%. The materialized views from other products and platforms, like for example, if you created materialized view in Oracle, if you have created materialized view in Netezza, those materialized views we can just copy the select statement and then do the same thing in dynamic table. Just paste it in dynamic table and you can do it. So drop-in replacement. But one thing to keep in mind, if your materialized view is super complex, you probably want to break it into a couple of dynamic table and daisy chain them together to get to your fact or to get to your goal layer.
Excellent.
That makes it easier for dynamic table to piecemeal and digest the information and then build your final outcome.
Awesome. Love to hear that. Thank you again for the demo. Really appreciate it. Thank you so much for being here, Parag. We're at time, so we're going to go ahead and wrap. Again, folks, if you have any more questions, ask them on the channel. We'll go back and answer them asynchronously. We can also provide the links to the GitHub repo and to the quick start. But I just want to say thank you again, Parag. Thank you, viewers, for tuning in. Appreciate it, and I will see you next time.
Thank you. Bye.